think about how we first used AI. Like, we treated it like literal magic.
Oh, absolutely. We really did.
You typed a secret spell into a text box, you hit enter, and you basically just hoped a miracle popped out.
Right. You crossed your fingers.
Yeah, but that magic spell era, it's officially dead.
Completely dead. We've moved from magic to, well, manufacturing.
It's been replaced by something much more industrial and, frankly, a whole lot more lucrative.
Mm-hmm.
Welcome to the deep dive. If you're listening right now, you might just use AI for, quick emails or summarizing articles.
Which is how most people still use it.
Right. But today, you'll see how the top tier actually operates. We are looking at a really fascinating stack of insights from AI Fire.
This great collection of data.
It really is. We're mapping out the true state of productivity in 2026.
And I got to tell you, the landscape looks completely different now.
Okay, let's unpack this. We're going to explore the fundamental shift from basic prompting to building automated systems.
Yeah, that's the big one.
We'll look at how solo entrepreneurs use this to scale like crazy. Then we'll dive into the strict security needed to keep AI workers from, going rogue.
Which is a real problem.
A huge problem. And finally, we'll tackle the billion-dollar physics problem underpinning all of this.
Because the hardware is literally hitting a wall.
Exactly. So we really have to rethink our baseline approach here. Casual usage of these tools is basically obsolete.
Yeah, the data from AI Fire paints a very clear picture. The top 9% of users, they just don't prompt the same way anymore.
They use what the sources call a reverse method.
Right. What's fascinating here is that they figure out the exact output they want first. Then they work backward to build a rigid system.
Mm-hmm.
They don't ask for one-off casual tasks. If your AI outputs currently feel a bit average, well, this is why.
Because a single prompt usually gives you an average result.
Exactly. A design system, though,
Right.
that gives you a reliable, repeatable engine.
So instead of asking a magic 8-ball for an answer, you're building with Lego blocks.
That's a perfect way to visualize it.
You snap a research block onto a writing block, and suddenly you have a repeatable machine. You're building a permanent structural foundation.
Yeah, take a tool like Notebook.LM, for example.
Mm-hmm.
Lots of people have massive databases of free prompts.
Oh, I have hundreds just sitting around.
Right. And usually those just get lost in random desktop folders. You never actually use them.
Oh, right. You hoard them, but you can't find them when you actually need them.
Exactly.
Yeah.
But in just 5 minutes, you can build a system to fix that. You take, say, 1,500 working prompts.
Okay.
You upload all those text files directly into Notebook.LM. And it turns that static database into a private retrieval system.
Wait, how does it actually retrieve them, though?
It uses semantic search. So you just tell Notebook.LM, I need to write a product launch email.
And it just knows.
It understands your intent, it digs through your 1,500 files, and pulls the exact prompt template you need.
Wow. So you never lose a good workflow again.
Never. And the foundational tools are evolving to support this system-level thinking. Look at Google AI Studio.
Right?
They just dropped a major full-stack update. The claim is that a single prompt can now build an entire startup.
Wait, I hear claims like that all the time on Twitter. I have to push back here a bit. Does the code actually compile, or is it just generating a buggy front-end template?
Oh, it's a fair question.
Yeah.
But it's actually compiling. It's doing this by creating a pipeline.
A pipeline.
Yeah. It spins up an AI for the front-end interface.
Mm-hmm.
Then it spins up another AI for the back-end database schema.
Mm-hmm.
And they actually talk to each other to resolve bugs before showing you the final result.
If we're shifting from single prompts to automated systems, doesn't that make the initial prompt less of a magic spell and more of a factory blueprint?
Yeah, what's fascinating here is the psychological shift in how we work.
Yeah.
A magic spell is deeply hopeful,
Right.
but a blueprint is highly structural. When you write a blueprint, you are actively defining constraints. You tell the AI exactly where the boundaries are.
You box it in.
Exactly. It stops being a random slot machine. It becomes a digital manufacturing line.
So we're acting as architects now, not just conversational partners.
Precisely. You design the factory floor. The AI just runs the machines.
And once you start building these blueprints, it totally changes the game. I mean, it completely changes the scale of what one person can do.
But it alters the entire economic landscape.
Yeah.
Solo founders are actually scaling faster than small teams right now.
That sounds impossible at first glance. How exactly are they doing it?
By completely ignoring the general hype around AI agents.
Really?
Yeah, they don't just deploy a generic AI and hope it figures things out. They take a complex business function, like marketing or customer service.
Okay.
They break it down into tiny, specific micro tasks. Then they rebuild those tasks as strict AI-driven pipelines.
So they systematically map out the entire workflow, step by step.
Yes, and it's proving to be incredibly effective. The sources highlight 7 specific AI businesses you can run absolutely solo.
Solo, like 0 employees.
0. They exclusively rely on Claude agents. Agents, meaning AI programs that complete tasks without human help.
And these solo operations are actually profitable today.
Very profitable. People are reliably hitting $10,000 a month.
Wow.
And they don't hire a single staff member. The Claude agents handle the actual daily labor.
Explain how one of those businesses actually works in practice. Like, give me an example.
Sure. Let's look at digital video creation. You can now reliably create highly engaging, faceless YouTube videos.
Faceless videos. Okay.
We're talking 1 to 30 minutes long. And you can do it entirely on a mobile phone.
No expensive camera equipment needed at all.
$0 spent on production. You just use a connected pipeline of free mobile tools.
How does the pipeline start?
First, a research agent finds trending topics. It passes that raw data to a scripting agent. The script goes to a synthetic voiceover API. And finally, a visual agent animates and edits the whole thing together.
Here's where it gets really interesting, and I have a vulnerable admission here. I still wrestle with prompt drift myself when trying to automate my own daily workflows. You know, you ask an AI to do 3 things.
And by step 4, it forgets the original instructions.
Exactly, it just wanders off.
Oh, everyone deals with prompt drift. It's so frustrating. But that's exactly why pipelines are so crucial.
Because they limit the scope.
Right. They lock the AI into a very narrow task. The script agent doesn't need to remember how to edit video. It just writes. The division of labor solves the memory drift.
Are we looking at the end of the traditional startup team or just a redefinition of what a team actually looks like?
We connect this to the bigger picture.
Right.
It's definitely a redefinition. The team is no longer physical humans sitting in a room.
Right.
The team is you managing a digital workforce.
Okay.
You are the sole human director.
So the team is now software managed by one human visionary.
Exactly right. You're the conductor. The AI plays all the instruments.
But there is a massive catch to all this. If your one-person empire relies entirely on these automated Claude agents, what happens when they break down? Or worse, what happens if they go rogue?
That's the ultimate nightmare scenario for any business. Everyone excitedly talks about the shiny new capabilities.
Yeah.
But almost nobody talks about what keeps these agents functionally alive.
Because everyday reliability is totally different from peak capability.
100%. The AI fire sources outline 5 must-have rules for building working agents. These are essential for daily life.
What kind of rules?
You need strict operational guardrails. For example, you have to implement distinct memory wipes between distinct tasks.
Right, because without those rules, we saw what happened with OpenClaw.
Yeah, the OpenClaw situation was a huge wake-up call for the industry. It was an open-source model given way too much autonomy.
Too much freedom.
Exactly. It had internet access and agentic tools, but it had no supervisory layer. It started hallucinating and executing code it shouldn't have.
It was leaking sensitive developer keys because it didn't have boundaries. A literal security nightmare.
It was a very serious vulnerability. If an agent has autonomy, it can make terrible mistakes.
Yeah.
But Jensen Huang just completely changed the game to fix this.
At GTC. Right.
Yeah, he announced a major shift at the recent GTC event. NVIDIA officially released NemoClaw.
NemoClaw. Okay, how does it actually work?
It acts as a strict digital cop for your AI workers. It's a secondary, smaller AI model. Its only job is to evaluate the main AI's actions before they execute. It ensures they never accidentally leak private files.
So it blocks them.
It physically stops them from acting purely on their own.
It sounds exactly like hiring a ruthless bouncer to protect your proprietary club. You check IDs at the door, and you throw out anyone breaking the house rules.
That's a really great visual.
If your AI agent tries to walk out the back door with your accounting data, the bouncer physically stops them.
Yeah, it intensely monitors every outbound network request the agent tries to make. If the agent tries to email a private financial document,
NemoClaw steps in.
Right, NemoClaw entirely blocks the action.
does putting a digital cop inside the system limit the AI's ability to be creative, or just keep it from burning down the house?
This raises an important question about trade-offs. Honestly, it's a bit of both. You do trade some wild, unconstrained creativity for strict safety. But think about it. In a serious business setting, you don't want wild creativity with your accounting data.
No, definitely
You want absolute predictability.
Safety protocols trade wild ideas for strict
necessary business predictability.
Exactly. You lock down the system to ensure the factory functions safely. Sponsor. Okay, so we have millions of solo entrepreneurs. They're running these highly secure, bouncer-protected AI agents. But to run all this software, the physical world actually has to keep up.
Right, and right now we're hitting a literal physical wall.
Because basic physics has an absolute speed limit, and traditional copper wiring just violently hit it. Why is copper suddenly the bad guy here?
It's a massive physical bottleneck. When you push electrons through copper wiring, it creates friction.
And friction creates heat.
Exactly. You simply can't push electrons through copper any faster without melting the cables. The electrical resistance is just too high.
So AI server farms are practically melting down trying to process these pipelines. How do we actually fix it?
We stop using electrons. We use light.
Light.
Yeah, NVIDIA just made a $7 billion bet on this. They're aggressively shifting to silicon photonics, which are light-based chips.
So they're swapping electricity for tiny lasers on a chip.
Exactly. Photons don't have the same physical resistance as electrons. They generate practically zero heat.
That's incredible.
And they move at, well, the literal speed of light. This specific technology will power the next generation of AI infrastructure.
2-sec silence. Whoa. Imagine scaling to 1 billion queries instantly just by swapping copper for actual light. That feels like science fiction.
It's completely mind-bending. It allows for massive data bandwidth that we couldn't even dream of with copper. It completely changes the physical hardware game.
But while NVIDIA spends billions trying to solve the physics problem, others are playing a totally different game.
Very true.
Highly efficient small models are hitting gold right now. And Apple is quietly operating a $900 million AI toll booth.
Yes, Apple's strategy is fascinating. They're making massive profits from AI apps on their App Store.
Just by sitting there.
Exactly. They don't even need to lead the AI capability race. They just effortlessly tax all the eventual winners.
They charge a 30% tax on the software layer. They don't care if the servers run on copper or light.
Right, they just own the platform.
Yeah.
Meanwhile, there's this deeply theoretical concept mentioned in the AI fire sources. It's called simurial.
Simurial. Okay.
The idea is that simurial equals AGI's IL. AGI, meaning AI that matches or exceeds human thinking.
How does simulating reality lead to human-level intelligence?
Well, if an AI can perfectly simulate complex physics-like light moving through a chip or fluid dynamics, it implies it truly understands the underlying rules of reality.
Oh, I see.
It's not just predicting tact anymore. It understands cause and effect in the physical world. That simulation capability might be the actual path to real-world AGI.
Eat. If NVIDIA is betting billions on light to solve the hardware bottleneck, does Apple's toll booth strategy make them the smartest player or the most vulnerable?
What's fascinating here is Apple's deep structural insulation. They completely own the final distribution to the consumer. As long as normal people use iPhones to access these AI agents, Apple gets paid.
Apple wins by owning the access point, regardless of the underlying hardware.
Spot on. They own the door, so they collect the cover charge.
So what does this all mean? Let's take a thoughtful step back.
We've covered a lot of crucial ground today. We moved from treating AI like a simple chatbot to building highly automated factories.
Right. It completely empowers the ambitious solo creator to scale like never before.
Yeah.
It actively forces a necessary revolution in digital security with tools like OpenClaw.
Absolutely.
And it demands a literal reinvention of baseline physics. We're rapidly moving toward entirely light-based computing just to keep the lights on.
It's essentially a complete industrial revolution, neatly compressed into a few short years. The software tools are already here. The rigid security is quickly catching up. And the physical hardware is mutating to survive.
Which naturally leaves us with a final thought to mull over. If one person can build a $10,000 a month business today using Claude agents and Lightspeed chips, what happens to the global economy when the cost of launching a Fortune 500 competitor drops to absolute zero?
Now that is a genuinely wild thought.
It really is. Take some focused time this week. Look closely at your own daily workflows. See if you can deliberately map them out as a rigid system, rather than just firing off a casual prompt.
Build those blueprints.
Remember, we're no longer casting hopeful magic spells. We are steadily building automated factories. Thanks for joining us on this deep dive. We'll catch you next time. OUTR Music.